In this video, we'll talk about the basics of graphing sine functions. Okay, so a basic discussion about the graph of sine so that we can kind of relate what we need and see how that would translate onto a graph. So first of all, let's make a list of what we need in order to be able to graph this. Okay, we're going to need, actually recall that the formula, like the function of sine, is a times sine of omega times x minus phi, where phi is phase shift, and then plus b. These are all the things. So if I am applying all four transformations, vertical stretch, horizontal stretch or compression, or this could be a vertical compression also, phase shift, so horizontal translation, and then vertical translation. Those are all the four possible things. So we are going to need, we're going to need the amplitude. Okay. Recall also that the amplitude, the way that would look on the graph, is how far it is from the center, from like the midline of the data to a top point, or same thing from the center to a bottom point. Those are both the amplitude. It's the same. Okay, so we can get amplitude, and it's just a. Then omega here has to do with the period. So from here to here is one period of this graph. In this case happens to be 2 pi because I've just graphed the basic y equals sine of x here. So I'm going to need to be able to get the period. Okay, I need to also know the vertical shift. So this midline happened to be right along the x-axis for this problem. But if it had gone up or down at all, that would be a vertical shift that I would have to indicate, and that is the b over here. Okay, so that's what it would be if I was adding or subtracting something from the outputs of the function. And then lastly, the horizontal translation. So that's this phase shift. That could either go right or left from our starting point. So every graph, each trig function kind of has a natural starting point, and for sine, it's at 0, 0. So we start kind of drawing sine at 0, 0. Now, one last thing to notice here is that it's possible to kind of divide this graph in one period up into 4 chunks. Okay, so we have like, or is that 4 chunks? Did I count that wrong? We have 1, 2, 3, 4 chunks. Okay, those 4 chunks kind of, if we have one period, we can divide a period into those 4 chunks, and if we can just plot these points where we start at a 0, we go up, we go back to the middle, we go down, we go back to the middle, I can pretty much draw in the rest of the graph. You can get more precise, but that's not really necessary. So let's dive into an example and see how it'll work. Okay, y equals 2 times the sine of 2x plus 2. So first of all, right away, 2 is the amplitude. That's easy. Okay, omega is 2, so the period is equal to 2 pi divided by omega, and 2 pi divided by 2 is just pi. So the period of this is pi. The phase shift, okay, if there was something in here after the x, if we were adding or subtracting from that x, then there would be a phase shift. But in this case, there isn't, so there is none. And then the vertical shift is this 2, we're going 2, and we usually indicate the direction by using an arrow. Okay, so there's a few things we could already transfer onto the graph. We know that the midline of this graph is going to be 2 up from 0. So we're going to have a midline, and I'm just going to use a dotted line to represent that. Okay, so that's like the middle of the data right there. I also know that the amplitude is 2, so I'm going to be able to go up to 2. I'm going to have top, like my maximum points are going to be up there, and then my minimum points are going to be 2 down from the midline. So I'm going to have a total like height of this graph is going to be 4. It's going to go up 2 and down 2. Okay, so that's kind of it for now. Now let's talk about how do we know how to label? How do we divide this thing up into its 4 chunks? And to do that, I like to call this a process called finding the tick marks. These are the tick marks that we would label on the x-axis. And the way we do that is we take the period, so in this case it's pi, and we divide it by 4. And so what this pi over 4 here is the distance between each tick mark. Now, I can start this at 0 because there's no phase shift. Okay, if there was a phase shift, I would start it at the phase shift. We have an example like that coming up soon. However, since this is 0, I know that this next tick mark I'm going to put is pi over 4, and then I'm going to add another pi over 4. So pi over 4 plus pi over 4 is pi over 2. And then I'm going to add another pi over 4, so there's going to be 3 pi over 4. And then another one, and that's going to be pi. Okay, now notice that pi is also the period, okay? So that makes sense. Now, all we have to do here is write in these common points. So if I was at, sine usually starts at 0, 0, but I've been shifted up 2. So there's my first point. Now on the next tick mark here, pi over 4, I know that sine goes up and it hits a maximum. It's like when we rotate through the unit circle, the y values increase until they get up to 90 degrees or pi over 2. But this omega means every pi over 2 would be we have a change in that. Okay, the next tick mark is going to be down at the center. Then the next tick mark is going to be down at the bottom, and then the last one is going to be pi. So now really all I have to do is just kind of sketch this graph in. So this is what the graph of 2 sine 2x plus 2 plus 2 looks like. Okay, it goes up. We choose kind of a smooth curve here, and then it goes down. Now, that's not it. All these sine functions are continuous and they're periodic, so this we can draw in these dotted lines with arrows on the end to indicate that it goes on and it repeats in this manner forever. But that's really just it. Okay, we're going to find the amplitude. We're going to look at the equation, find the amplitude, the period, the phase shift, the vertical shift, use the period to find the tick marks, plot everything, and then go. Here's another example. So here we have y equals 3 times the sine of x minus pi over 4 minus 1. All right, so 3, boom, amplitude is 3. Period, the number in front of the x here, omega, is just 1, right? So if the period is equal to 2 pi over omega, well, in this case, our period is just 2 pi. It's the standard period for sine. Hey, now I have a phase shift, right? This negative pi over 4 means I have a phase shift of pi over 4, and if I'm subtracting from my x values, what that results in is the graph shifts pi over 4 to the right. Then I also have a vertical shift here of negative 1, so I go 1 and I'm going down because I'm subtracting values. So that's cool. Now let's put all that information, let's put most of that information now on the graph. So we've got our vertical shift of 1, like let's put a tick mark here on the vertical axis, that's 1. Okay, that's 2, 3, 4. So negative 1, negative 4 down here, and we'll go also up 3. Okay, so that's 2. And now we have our midline is going to be here at negative 1. Okay, we know that we're going to be going up to 2 and down to negative 4 because our amplitude is 3. So 3 up and 3 down from negative 4 is our maximums and our minimums. So the last thing I need to do is figure out what these tick marks are going to do. So tick marks, I'm going to take that period, which is 2 pi, and I'm going to divide it by 4, which means that each tick mark is going to be pi over 2 away from the previous one. However, I'm starting my tick marks at pi over 4. So my first one is going to be at pi over 4. And then from pi, I'm going to add pi over 2 to pi over 4. So pi over 2 is the same thing as 2 pi over 4. So if we add 2 pi over 4 to 1 pi over 4, we get 3 pi over 4. If I add another 2 pi over 4 to this, I will have 5 pi over 4. If I add another 2 pi, I'll have 2 pi over 4, I'll have 7 pi over 4. And then another one I'll have 9 pi over 4. Okay, so those are my tick marks. Those are where I'm going to, and I know that pi over 4 is like to the right of 0, right? So like ultimately, here's 0. Pi over 4, let's say that pi over 4 is right here. Okay, in that case, 2 times that distance would be pi over 2. So if I go 2 times that distance, I'll have another tick mark right there, another one like right there, another one right there, and then a last one right there. And so if we label these, we know that this is pi over 4. We know that this is 3 pi over 4. This is, I'm just reading this off the list we generated, 5 pi over 4, 7 pi over 4, 9 pi over 4. Okay, and now all I need to do is just do the pattern for sine. So sine starts at, it would start at 0, 0, but instead it's starting at 0, comma, negative 1, and that it's going to start at 0, comma, pi over 4, comma, negative 1, right? Because we've got that phase shift. So then the next point, on the next tick mark here, we're going to have a maximum, so we're going to be up at 2. Try to make a circle there. It didn't quite work. Then at the next tick mark, we're going to be back at the midline. At the next tick mark, we're going to be down at -4, somewhere right about right there. And then at the last tick mark, we're going to be back at the midline. And so all I'm going to do is sketch that in with a smooth curve. I've heard somebody call these like happy faces and sad faces, kind of. They don't go quite vertical. They kind of just, it's a smooth curve. And again, we have to indicate that this just keeps going on forever by drawing in a dotted line with arrows on the end. And that's it. That's the graph of 3 times the sine of x minus pi over 4 minus 1. Let's look at one more example. All right, so this one, y equals negative sine times 2 times x plus pi over 2. All right, first of all, the number in front of sine here is -1. However, that just means an amplitude of 1, because my amplitude could be up or down. But that minus means we're going to have to flip everything vertically. That's what I'm multiplying by a negative value does. The period, we look at the omega of 2 to find a period, so we would have t is equal to 2 pi divided by omega, so 2 pi over 2, which is just pi. Okay, so the period of this is pi. The phase shift here is pi over 2, and it's pi over 2 to the left, right? Pi over 2 to the left. And then there is no vertical shift for this one. Okay, so let's put this stuff on here. We know the midline is already there on the x-axis. Don't have to worry about that. You know the amplitude is 1, so we go 1 up and 1 down. Okay, and now let's look at these tick marks. So the tick marks, we're going to look at the period. So Tn for tick marks. The period is pi, and then divide that by 4, because we're going to have these 4 tick marks, actually 5. In addition to our, including our starting one. So they're going to be pi over 4 away from each other, and our first tick mark is actually going to be at negative pi over 2. So I should have set this up a little differently and had the x-axis extend into the negatives. So what that means is I will have one tick mark right here. I'll have another tick mark right there. I'll have another tick mark at the x-axis. So where do the tick marks start? Let's do that. We had negative pi over 2. Then we add pi over 4 to that, we have negative pi over 4. If we add pi over 4 to that, we have 0. If we add pi over 4 to that, we have pi over 4. Add pi over 4 to that, we have a positive pi over 2. So that means our next one would be about right here, and then right here. And then if we label that, we'll have negative pi over 2. We have negative pi over 4, obviously 0. We have positive pi over 2, and pi over 4, and then pi over 2. Okay, so there was no vertical shift. However, there is this negative thing. So where we would be normally starting at 0, 0, we're actually going to be starting at negative pi over 2 comma 0. Okay, so there's our first thing. Now, instead of going up like we normally would with sine at this next tick mark, we're going to actually be going down because of this negative. So our next tick mark, negative pi over 4, we're going to be down at the minimum. So right there. The next tick mark will be back at the midline. The next tick mark will be back at the pi over 4. The next tick mark will be back at the midline. If we wanted to keep going, we totally could, because this pattern would just keep doing the same thing, okay? Every pi over 4, we'd be alternating like that. So if we are at the middle, then we'd be back down to the bottom, then back to the middle, then back to the top, then back to the bottom. And so if we graph this now, we would go like this. We'd go smooth. We connect it with a smooth curve. We do our best job. It's pretty hard on this tablet, but I'm doing my best. Oop, that was not very good. Okay, and we could keep going on this indefinitely because it's a periodic function. It's going to keep repeating in that way. And so that is how you graph. That is how you graph. You interpret all the different transformations of a sine function and get them graphed. And pretty much that process applies to all of the trig functions, and we'll see examples of that as we go through the trig unit.